Hello everybody, today I'm going to talk about the 16 concepts of Eureka. As you can see, my demonstrated object that's going to be relevant to all these 16 principles is in house. Here's an image of Eureka, our old TV show in the old days. And as I mentioned earlier, the selected object for demonstration is in house, the 16 principles of Eureka. So our first principle of Eureka is called inertia. And inertia is the science where the tendency to do nothing or to remain unchanged. If an object has a lot of mass into it, it will take a lot of force to make it move. It's because it's lazy and it's inertia. However, if you throw a rock in space, and since there's no gravity in space, the rock will not start moving, will not stop moving because of inertia. So here's the next one, mass. The large body of matter with no definite shape. This weight bar, for an example, which is going to come later, is going to show how much mass it has. As you can see, a house has a lot of inertia and mass in it, depending on how big it is. And here's the weight bar, it's 100 pounds, which is a lot of mass, pretty much. So our third principle of of Eureka is gravity. When the core of the Earth attracts all living objects that have mass, to the center of Earth. So Earth has gravity, but space does not. So this is why your house is not floating around. It's because of gravity. It's staying in place and inside your objects as well. And here's an image of an apple falling on Newton, which actually. Then comes weight versus mass. Now, one major difference of weight versus mass is that your mass won't change on space, but your weight will. Due to gravity, this is all happening. And so, yeah, this is what weight and mass is. Your image of the moon here. So, next comes molecules. Now, molecules are little, really small particles made out of atoms, even smaller particles. Every matter is made out of molecules and atoms, including, of course, an house. Here's a molecule, since there's no real image, because they're so small. So then comes molecules and liquids. Now this is very interesting. Have you ever wondered why your ice cream melts? Well, it's because of heat, obviously, but the heat starts making the molecules go energetic, which starts getting chaotic and starts passing on each other, which means the ice cream can't be a solid anymore, and it turns into a liquid. So here's how it works. This ice cream cone right here, my ice cream, is going to melt now, since the molecules start getting chaotic and passing on each other. So this is the final result, since it's not a solid anymore. So then comes evaporation and vapor. So let's take a fishbowl for an example that is right next to the window and the sun is shining right at it. Well, did you know that the molecules will start coming out and start making this invisible gas called vapor? This process is called evaporation. Here's an image of my fishbowl. So then comes expansion and contraction. Now, when, let's say, your house is cold, things that are able to contract will get contract, so there will contraction. That is called contraction. And like, let's take a football for an example, will start deflating. And if the heater's on your house, then things will expand. Atoms. As you can see, atoms are small particles that create molecules, which we mentioned in the other part. Now, everything is made out of atoms. Every single matter is made out of atoms. Even of course, this home is made out of atoms. Every atom has a nucleus inside it, and there are electrons whizzing around the nucleus. So they're even things smaller than the protons. Then comes electrons. So electrons are things that are whizzing around the atoms. They're whizzing around the nucleus, which is inside an atom. So here's what the nucleus looks like, and here are the electrons. Then comes conduction. Conduction is the process where heat and electricity are being transferred to other objects or matter. their metal is a really good conductor, but plastic and wood are bad conductors. Let's take a toy car for an example. It's and leave it right next to the window where the sun is shining. It's most likely that the car is going to get hot because that's called conduction. And here's the image of heat transfer right here. So then comes volume and density. Now these guys play a really important role in science. As you can see, mass divided by volume equals density, and volume times density equals mass. How is volume and density related to a house? Well, of course, a house is measured in volume. Buoyancy. Now this is buoyancy, referred to a buoy. Buoyancy is when some object is the ability to float on water or any other phenomenon. So yeah, buoyancy is when hotter fluids make it rise and colder fluids make it sink, which are the principles of convection. So as you can see, convection right here is when the principle of hot fluids and cold fluids. The biggest rule of convection is that hot fluids rise and cold fluids sink. So if you remember why the second story of a house is hot, it's because of convection. The hotter fluids rise and colder fluids sink. Heat as energy. So heat as energy, or heat energy, is a form of energy. Where it gets. And then radiation waves. Have you ever wondered why it's so hot in the sun? Well, yes, because of heat. But you're not touching it. This is called radiation wave. It sends waves of heat. This is called radiation. So yes, heat as energy is when heat turns into energy because molecules start getting energetic. Anyways, thank you for watching this, and yeah, thank you for watching this, and I hope you enjoyed it.